Hi everyone from Intersolar. We are here, OxfordPV, and today Dr. Ed Crossland will explain everything about perovskite. So thank you for accepting this interview. First of all, Mr. Crossland, what makes perovskite solar cell different from traditional silicon-based panels?
Sure. So on the outside, it looks nothing different. It simply looks like a silicon normal panel. There are two terminals coming out, and there are cells in the middle. In a perovskite silicon tandem solar cell, we've combined two solar cells into every single cell in the panel, and that gives you more power per cell. When you have two solar cells acting in parallel, you can generate more energy by collecting more of the energy from the solar spectrum instantly on the panel. And still on the outside looks the same. There's still only two terminals coming out, and what you get is a high-power solar panel. We say that the perovskite silicon tandem panel starts where the silicon panel ends. So every benefit from the silicon improving is basically improved upon by having the perovskite cell in front of it. And we have a roadmap going into the 30%, 35% module efficiencies from perovskite silicon tandem. The theoretical efficiency limit for a perovskite silicon tandem cell is 43%. Compared to only 29% theoretical maximum for a single junction silicon cell. So you can see the tandem cell has the potential to go take the roadmap for solar panel efficiency beyond where the silicon panel can go.
That's great. What are the main challenges for this new technology to commercializing?
Sure. So we've gone through an enormous program of R&D to develop the technology to the stage where we can offer efficiencies beyond the silicon panel already. We've also done an enormous amount of work showing that standard deposition and manufacturing equipment can be used to form the perovskite silicon tandem cell integrated together so that it looks no different to the silicon cell before, but using standard commercial tool platforms. The challenge that remains is to show then in the large productivity platform at larger volumes than we're so far reached that this can be done cost effectively and that it reaches panel yield and quality conditions that enable mass deployment.
Okay, last question. How could really perovskite solar panels impact the global solar energy market? What do you think?
Okay, so efficiency gets you everything, right? So in any application that you consider applying solar, a higher power per module will always be beneficial at a reasonable cost point. That reasonable cost point and power premium depends on the application, and by raising the efficiency of the panel and the cells, you raise the number of applications in which solar makes sense. So it could be distributed, lightweight, mobile solar in the aerospace or mobile vehicles, or it could be in all of the space-limited applications where land is at a premium, so it's always going to be an advantage to either use less land or generate more power for the land that is available in any particular location, be it rooftop or utility field. So provided that we can, our roadmap says that we will meet the efficiency and field reliability targets for the technology, then these benefits will just expand already, so accelerate what is already a rapid deployment of solar.
It's amazing. Thank you.
Thank you very much.